Okay, so what I realized is that one of the things that we should maybe change is that I don't think, you know, with the stuff like Ghostwriter, I don't think we need to actually, for this first stage, really rely on any libraries. I think we can just, we might just as well ask it for everything. So, oh my God, where was I? It's been like 5 days or something, so a lot going on. So I'm gonna get rid of these. And we'll just keep it as thin as possible. That's going to be super inefficient, I'm sure of it. KJS, Circuit.js. Yeah, okay, so that's all stuff. We just we just kept everything in here at the moment. And yeah, this is where exactly. So cron. So what I will do is the following. So let me code for the Chroniker product of two matrices function. I'm gonna assume it's correct. I'm just really gonna assume it's correct, yeah. And you know, these kind of this will definitely go into a library at some point, right? So at some point this is just going to be outsourced to a proper library. I'm not so sure going to get there at all, but yeah. So no. So I have these, and now basically what we want to do is rewrite this function. So rewrite this using our cron function instead. This is actually awesome. So okay, I'm not even, although I like the way that someone put it, it's like, do not ever run code that you haven't checked yourself, even if it comes from a human. So we're gonna take this, we're gonna do boom, and what is it doing? So it's okay. So update state vectors. Let's recall where were we at the moment when we build that. So column, so we want to basically have column matrices. So when we have column matrices, then we can just multiply them all, and then we have the state at any given column, so to say. You know, this might be inefficient, but you know, let's stick with this for now. So here for each column, then we get all the gates, okay. And then basically we say gates reduce. I have no idea how reduce works. I never used it before. Accumulator current value, cron accumulator current value. I think this so what's reduce doing? The reduce method takes a function as an argument and applies it to each element of the array. Okay, so it takes that function, that function that returns. I'm not so sure how is this mapping. I've never used these things before, so I don't know if that really works well or not. But we'll see. We can do a quick test right away. So yeah, so it keeps applying this. So it applies accumulator current value. how can I interpret this input? Okay, so that's it's a function declaration that takes 2 arguments and returns the result of applying the cron function to them. So that's just a shorthand for a function. I didn't know that. And it returns accumulated cron value. But where are these things defined? Cron. Yeah, okay, but can this really be done like that? Like gates reduce the first argument represents the accumulated value from the previous iterations of the reduce method. Yeah, let's hope that works. But you see, these are things that I would have never. I just don't have the time to learn. It's just useless to learn this kind of stuff, you know. And as I said, what's funny about all this is that, like, I'm not kidding, but you know, if the code is being generated by GoTrider anyway, so at some point, how much more, how much sense do libraries still make? As in, like, the concept of building code with libraries and stuff like that, right? I mean, one could argue, well, this is what it got us where we are now. It still makes sense, right? Because it's more to just code. It's like how you build, how you ship stuff, how you have dependencies, and so you don't have to carry all your code around all the time and stuff like that. That makes still sense. But it's like for quick prototyping, it's awesome because you can just quickly, if all you need is these, right? If all you need is these function here, then you just ask it to write a quick one for you, and just write a quick one for you, even if it's inefficient, and then you can later on replace it with a library. So I think that's actually cool. Okay, let's test that. So now we have in column matrices, we have all the matrices. So this is another thing. So what I wanted to do now is here console log column matrices after each column iteration. Let's see what happens. And am I calling these finally? Update state vector. Is this being called somewhere? Yes, it's being called here after loading the circuit. Cron is not defined. Well, it is defined, my friend. Cron. How do I... Well, it is defined. It says cron is not defined. No, it is defined. Yeah, that's how it's done. It's inside the circuit. Oh, maybe I have to I have to just call it like this. That would have been the right answer, my friend, I think. Console away. Okay, no, then let's console, exactly. Okay, let's see. Can I pretty print a matrix? So give me, that's also the great thing. Function to pretty print a matrix. Exactly. So get this one. So this is just a test function. Okay, so we're definitely gonna get rid of this at some point, just for testing purposes. And then we are gonna print matrix. So what we're gonna do is we're going to print the actual, not the whole array, but like the one we just calculated. Column matrix. Exactly. Okay. But give me a second. So which is which? I'm not so sure. Why lock? Won't print. Oh no, it's console. Is it lock or is it print? It's lock. Call. That's awesome. It's great autocomplete. Okay. Yeah, essentially they're, of course, two are the same, right? So let's see. First of all, let's do a... It looks good because it's 2 qubits, so it's like a 4x4. Yeah, for sure. What if I give it a... you know, what if I just say... That's like this, and that's like this. Yeah. I think that also kind of makes sense. I will have to compare. How could I test? Well, the easiest way to test it is then, you know, kind of then do the whole multiplication and then see, you know, give it a starting state and then yep, exactly. So now, but it seems okay. I mean, if I give it just an easier one to check, at least the 0.7 makes sense. And there's no imaginary component. What if I give it to test? What if I just give it like y? Let's just do a simpler circuit, okay? So it's gonna be easier. So it's just these. Oh, look at this. Here we have some odd numbers. That's not nice, and that's probably because of the complex number. Because that... Oh, am I using... I think I should iterate in reverse. I think that is the... That should be the lowest end qubit, and you know what I mean? What I'm trying to... It gets parsed like this. I'm not so sure I like these. Is it doing correctly for 2 qubits? That should be easy, yeah. And then shouldn't that just be... I'm not so sure that's correct. Like if I... Can I check with Quirk maybe? Quirk. So our Chronicle product might not be just working as expected. If I check this and I want to see... No, what is the... I want to see a density matrix. Is that what I want? That's definitely not. No, that's not what I'm looking at. No. I need the matrix, but there's no way to look at it here, I think. We'll go try to know. So what's the matrix of a 2-qubit operation where only an X gate to the first qubit is applied. Hold it now. Okay, so it seems to actually, it has a Kronecker product. Yeah, no, okay, makes sense. Yeah, true, it makes sense. So this is all zeros, and then you've got the ones in here. And here we got, because I think it's the second qubit, right? So I think it treats that as the second qubit. Yeah, okay, but we just have to figure out how to test it, and then yeah, but it's also not doing it correctly. Because if I multiply these, so if I have an array, which is basically, I just want to do a quick test, okay? So so test state is basically an array that is like, so that's essentially telling me that this is the 0, state, and they should basically what it should do at the end is it should move it to either the one to either this one or this one. So if I do basically multiply, so the normal inner product, let's assume that one is correct as well. So matrix multiply. So now what I want to do is I'm here, and I want to do another test here, and then basically say, so this is a state test, and then essentially what is happening here is we want to do these matrix multiply, and we want to multiply. I think that you got to do it like this, right? These sort of these times these, and then print this. It's gonna do it. Test state not defined. Do I have to say let? I lost notion of like how you do this kind of stuff in here. Oh, and obviously pretty print. Maybe indeed the ordering was the wrong one. Or the multiplication function is too fixed. Is this function expecting length? Too fixed. Where is this pretty print? Okay. What if I remove this? This may be like an undefined. Yeah. Okay. Something's not right here. I think in the way this is currently working. I think I need to test two things. I need to test that the Kronecker product function really works, and that's what it's supposed to do, and that the matrix multiply does also its job correctly. Because essentially what I want to do is basically apply oh, unless oh, that's a vector. Yeah, I think that's where I have to. That's where I have to move next. So probably should clean up some of this a little bit because it's a bit messy. Just put it a bit aside, all these different helping functions. Yeah, and then see if that works. But essentially, that's once I get this to work, then I have a mechanism to calculate sort of the state at each column, and then off we go. Then I just need to go finish all the visual stuff, and we will be done. Yeah, it's this kind of things like I need to kind of, I feel like I need to develop maybe a mechanism to use the power of Ghostwriter better. So basically to kind of iterate faster, as in like, how do I quickly check that this is, you know, I could also just ask, hey, can you give me some test cases for cron, right? I think we could as well just do that, yeah. Cool. That's good. Perfect. Yeah, bye. Have a good day, guys.